in. All right, so again, just make sure you're adding the Google Classroom. If you're highlighted in yellow, that means you haven't added the Google Classroom yet. And that's a good way for me to keep track of how you're doing in the class, just to see if you're keeping on pace, if I have to reach out and be like, hey, let's make an appointment. It's just a good way of doing that. And we're not doing geometry. You guys are probably done with geometry by now. And if you're not and you're still working on it, because I know some of you might still be working on it, you can always make appointments with me separate, because GeoGebra is a pain. There's some assignments that take me longer than others, and that's me who's already worked with GeoGebra before. So if you guys still want to work on your geometry while you're taking this class, that's perfectly fine. Just make an appointment with me. So let's get into, what class is this? Algebra 2. All right. So if you guys haven't finished your practice or mastery tests, make sure to make an appointment with me. That way we can catch you up on this. What I've been telling people is the application is just practice problems that will be on the mastery test. Maybe it's a little different, but for the most part, it's gonna be very similar. So if you guys are still kind of like working on your practice, or your mastery tests, and you guys just know you need that extra help, it's not a problem. Not everybody learns the same. I try to teach in a way that's easy for everyone to understand. But if you're not understanding and you don't want to ask a question, just make an appointment with me. That's perfectly fine. So we're going to review equations and inequalities for the second module. So let's get into it. Equations are what we know as having that equal sign. Not everything has, that equal sign. Sometimes you want less than, sometimes you want more than, you know. So when we're dealing with these types of problems, so this introduction is going to talk about inequalities and stuff. So again, one trick that I want to teach you guys, and honestly, it's been taught for years, and I still haven't thought of a better way of teaching it, is you want to think of an inequality as an alligator. It's always going to eat what's bigger. So if you want to say greater than, like you want to say x is greater than 5, think of the sentence in your head, x is greater than 5. The alligator wants to eat the bigger number, so it wants to eat x. If you're saying x is less than 5, you're saying x is too small for the alligator to care, so it's going to eat the 5. And then you might see this little equal sign. It's either greater than or equal to or less than or equal to. And then we'll get into those right now. So let's talk about their inequalities. So it's reviewing inequalities right now. Linear, absolute values, all this. So we'll get it. So basically any type of function can be an inequality is what this thing is saying. And it's giving us examples here of an equation. So just remember when we're solving for a value, we're just doing the opposite. So if we're dividing by 5, 1/5 is the same thing as dividing by 5. We're going to multiply by 5. If we're subtracting 3, we have to do the opposite, which is adding. This is all this is going to go into. One of the things you want to remember for absolute value, in case you guys are having trouble with absolute value, is this idea that it's always positive. So that's what I like to call the distance. The distance is always positive. Even if it's on the negative side, you don't say, I walked -7 things there. You always just say, I walked 7 feet. I walked this. So this usually, when we use absolute value, we're usually talking about distance. The negative in this case is just talking about the position. If you walk this way, you're walking to the right. If you walk this way, you're walking to the left. How do you show that in numbers? Well, you show that in numbers by putting a negative. But if you're talking about how far you traveled, that's your absolute value. All right. And then let's keep going. And the way you solve these is, I like to call it, you branch them out. So if you guys have taken me for Algebra 1, you've probably heard me say, what do you do when you get to your absolute value? You're going to split it. You're going to split it with one of them is the positive and the other one is the negative. And this works for inequalities too. I'm not sure if you guys have ever done this where you have a less than, negative x is less than -7. What happens here is you want to change all of your signs. So this flips over to greater than. So whenever you're, get rid of that. I don't know what that is. Whenever you switch your signs, whenever you're dividing or multiplying, all the signs change, including this one. I'm sure they're going to talk about this later, but I just kind of want to cover it now. So when we're doing something like absolute value of x is equal, or let's say less than or equal to 7, you're going to do one with your positive, but the negative one also flips over. We'll get into that later, but it's just this idea that if you're switching this sign for the 7, you have to switch this sign too. I'm sorry, I know I'm cramming this in there. This is going to teach you like a slower pace. So again, we're just talking about how to solve. Is everybody good with solving equations, by the way? I know I keep skipping this, but do you guys know how to solve for x and stuff like that? Is that a good assumption? Does anyone want me to review it some more? Okay. So just remember the idea of solving for x. I'll just do a little quick little intro since I'm sure you guys just might want like a little review. I always do this little trick where I want to solve for x. Well, how do I get to x? Well, I have to get rid of this 3 first. Well, before I get rid of that 3, I have to get rid of this 8. You're kind of working outside going in. So the first thing I want to do is I want to get rid of this 8. So I'm going to add the 8 to both sides. Now I want to go more inside. So I'm going to start trying to get rid of this 3. Well, how do I get rid of this 3? Well, I have to divide by 3. So that's a good kind of way of thinking about it. A lot of people think backwards PEMDAS. Oops. And that's good, but then you have to kind of be like, well, while I'm in the parentheses, I have to do all this. So if you guys want like a quick, easy way of thinking about it, I always think first you do this circle, then the outer circle, then the outer circle. So you work from your outside going in. Another trick, proportion problems. This is like when you have something like miles per hour is equal to, let's say, meters per second. It's basically a fraction equal to a fraction. From now on, guys, every time you see a fraction equal to a fraction, cross multiply. Anytime you see a fraction equal to a fraction, that's when you cross multiply. A lot of people think that when they have something like this, like a fraction times a fraction, it's like, oh, that means cross multiply, right? It doesn't. You cross multiply when it's fraction equal to a fraction. When it's a fraction times a fraction, you just multiply straight across. So only when there's this idea of equal to, that's when you do cross multiplication. So that's just like a quick little review. I'm going to skim through this real quick. Again, we're working from the outside going in, so you might want to do distributive property or factoring. If you guys haven't done factoring in a while, we get into that a little bit later. So for the most part, we're just going to be solving equations. The opposite of a square is a square root. How do we solve for an absolute value? We're going to split it. Factoring, again, we're going to work on factoring a little bit more. So perfect squares. For factoring, I always use the box method. If we get to factoring more, I'm going to review the box method, so don't worry about that. I think they're going into way too much detail here, so I'm just going to skip it because I know some of these come into play later on. So in the chat, or if you guys want to use your mic, what's the first step I'm going to do with in this problem? You could, but we're trying to get this S by itself, right? So you could do that. But that's more for when you're adding them together. You can't add them because they're not like terms. But that's a good point. If you were adding this and they were like terms, you would put an invisible one there. Anybody else want to give it a try? But that's a good point. If you're adding, you do want to put an invisible one. Right now, we're not adding. We want to get rid of this 11. Subtract 11 from both sides. Yep. So Angie's got it. We want to subtract this 11 from both sides. So first we're going to do that. We have more negatives than positives, so we're going to have -4 left over. I just kind of have this memorized. But if you want a visual aid, you can imagine that you have these 7 positive numbers and you have 11 negative numbers, and they're going to cross out until you're left with these 4 negative numbers at the end. So we're going to do this -4 equals 1 over s, or 1 over 6 times s. Here's a tip, guys. If you guys don't know what to do, you're going to use Sammy's trick. You're going to put a 1 here, and then you just multiply straight across. So that's going to give you the 6 divided, or s divided by 6. So how am I going to get rid of this divided by 6, guys? Yep, multiply by 6. Yeah, good job. So we're going to multiply by 6 on both sides. So that's going to leave us with -24. I forget if it wants us to say s is equal to -24. Let's find out together. Oh, you can't type in letters? So our answer is going to be -24. Yep. Well, good job, guys. I'll try to make it a little more interactive. That way you guys aren't just like listening to me. So what is the absolute value of 4? Anyone just want to shout it out? What's the absolute value of 4? 4. Yeah, exactly. Absolute value means it cannot be negative. So our answer is just 4. Easy peasy. Moving on. So now it's going to want us to try to graph these together. So, oops, I didn't know I was supposed to click on the answer, even though it says click on the answer. So, first things first, what do I have to do here, guys? What's the first thing I want to get rid of to solve for this x? Yeah, we want to get rid of this -12. How are we going to get rid of that -12, though? Yeah, we're going to add the -12. So now we have the absolute value of 2x equals, so if I add 12 to both sides, I have more positives than I have negatives. So I subtract these. Whenever you see two things that are different, think the word difference. That means subtract. So we're going to subtract this. And because I have more positives than negatives, 12 minus 2, that's going to be 10. So now, what do I do when I have this absolute value, guys? What was that trick I said? Absolute values do mean always positive, but inside the absolute value, it can be negative. It just turns it positive. So this, basically, that's going to be a check for this. Is this a positive number? It is a positive number. So we're good to go there. But what do I do to solve for this x? Not yet. I want to get rid of this absolute value first. So what I want to do before I divide by 2 is I have to think, well, what if I have a -10 in here? And if I have a positive 10 in here, it's the same thing. So this has 2 answers. So whenever you guys are solving absolute values, you're going to split it. So if you see an absolute value and you already are at this point, you're like, how do I get rid of an absolute value? The only way to get rid of an absolute value is to split it. One of them has the positive answer, the other one has the negative answer. And this is going to give you two things because now, as I'm not sure who said it, I want to say it was Brianna. Um, now we can divide by 2. So now we get this positive 5, and on this other side, we get this negative 5. So that's why the answer here isn't this one. I didn't mean to click on this. But our answer is actually this one. It's going to have a positive 5 and a negative 5. This absolute value gives us 2 answers. What if the absolute value was negative, and what if the absolute value was positive? So if you see an absolute value, that's a hint that you're probably going to have 2 answers. All right, so choose the correct problem that represents this. So we want to say that the hardware store sells fewer. So the keyword here is going to be fewer lawnmowers in July. If 39 lawnmowers were sold in July, how many were sold in April? So in other words, we want to take this, and when we're dealing about percents, guys, think of them as decimals. So if we're talking about an entire decimal or an entire number, it's a 1. 1 is 100%. So think of it this way. We want to take July, so sells fewer lawnmowers in July. So April is more than July. April is greater than July. We're not going to use inequalities. I'm just kind of walking you guys through it. So April is equal to 1, right? Just for argument's sake, we're going to say April is equal to 1A. So April is equal to 1A. But July is equal to 1 minus 0.35 of A. Does that kind of make sense? This is a little hard to understand, so if you guys are having trouble with it, what we're saying is we're talking about 35% less, fewer. This word fewer probably means we're going to subtract. So we're subtracting 35% from 100%. So 100 minus 35 is 65. So in other words, it's 1 minus 0.35. Is this kind of making sense, guys? Percents are a little tricky. Yes, no, maybe? Want me to go over it a little bit more? Yeah, so it's weird because what we're doing is we're taking 100% minus 35. So 35 fewer is actually 0.65, and I'll talk about that in a bit. But it's this idea that we take 100% of July and we take away 35%. So, in other words, July equals 0.65 of April. So, if April is 39, so July, 39 were sold in July. So, we're going to say 39 equals 0.65 of April. Or what they're doing, what are they doing here? Oh, it's right here. They just wrote it backwards. That confused me. So again, since an equal sign is kind of like a weights and measures, like it's basically this weight, you can switch them around and it's okay. So our answer is going to be this bottom one. So percents are weird because you kind of have to think it's not 35% of April, it's 65% of April. All right, so this one, I don't know why they're giving you one of these so soon, guys. So we're going to have to talk about factoring. Think of factoring as backwards distributed property. So you know how like if I had an x and then x minus 5, I would have to distribute this? Well, another way of thinking about this is let's say I already had that x squared minus 5x and I wanted to factor something out. So the way you think about this is, oh, I can divide both of them by x, which means I can take out an x and have x minus 5. That's what factoring is. We're dividing by something. For those of you who have done the box method before in algebra, you can use the box method with this. It's just a little weird. What it would be x squared minus 5. What times what gives us x squared? X times x gives us x squared. Okay, that makes sense. Well, x times what gives us negative 5? Oh, negative 5. So in other words, we can have x minus 5. I'll get into this a little bit more. This one's going to be a little challenging because it is reviewing what you guys learned in Algebra 1. So hopefully there's not that many of these on the test. If you find that there's a lot on the practice or the application, let me know and we'll kind of go over it some more. But what we're basically going to do here is now that we got to this point, there's this rule with zero called the zero product property. You guys don't have to like remember this, but it's just thinking about zero product property. It's this idea that 0 times anything is 0. So if I make this 0, everything is 0, right? 0 times anything. So 0 times, it doesn't even matter what this is. If this is 0, it's going to be 0, right? 0 times a million is still 0. So what I'm going to ask us to do is minus 5. What do I have to plug into here to make it 0? What do I have to plug into this x to make it 0? Anybody? Yeah. Uh-huh. What about 0? Yep, that's exactly the answer I was looking for, Sammy. So this is what we want. We want this to be 0. So, but what about this x? This x is this whole thing. This is the whole zero product property. So what do you guys think I can plug into this x? Think of this as a different x. What can I plug into here to make this whole thing right here 0? Yeah, exactly. I can plug in a 5. So I have two answers here. So we're going to separate those with a comma. That's why it says separate these with a comma. So we're going to have 0, comma, 5. Oops, I don't know why it turned into a... Oh, I guess a space bar makes it a fraction, guys, just so you know. So we have 0 and 5 as our answers. And that's how we're going to be doing these. So again, I know it's a little tricky doing the square roots or the quadratics because we haven't really gotten into them yet, but we will. So if you guys ever need help, don't be afraid to speak out, all right? Ooh, wow, they're really going to quadratics in this one. So I'm going to teach you guys the box method because apparently for some reason this lesson really wants us to know how to do quadratics. Whenever you see the square, think about it. It's x squared. So picture a square in your head. So then what we're going to do here is we're going to have this x squared here. And we want all of our squareds to be in this first box. So the first thing goes in the first box. The last thing goes in the last box. Normally, when we see a quadratic, it looks something like this. So there's usually a number in the middle. This one doesn't have that number. So we don't have to worry about it too much. Again, I know it's been a while since you guys have taken Algebra 1, so I don't expect you guys to remember how to factor completely yet. So we have a 0 here. So x times x gives us 0. We know that. What times what gives us negative 25? Negative 5 and positive 5. Yeah, that's right. And what this box method does is it gives us a trick to figure out how to get this 0. So let's see if this works. Negative 5 times x, negative 5x. X times 5, that's 5x. And then if we combine these two, we get 0. They both cancel out. So we have two answers here. We have this negative 5x and this positive 5. So going back to this, what can I plug into here to make this 0? What can I put into the first parentheses to make it 0? Yeah, positive 5. What about the next parentheses? Yeah. So it's important to remember that it's always kind of the opposite of whatever's in this box. Good job, guys. All right, so let's move on. So now we're going to be dealing with another type of quadratic. So they really want to do these quadratics. So again, nothing to worry about. We're just going to use our little box because we see that square. And we're going to put an x squared here. We're going to put this 4 in here. So actually, let me use a little trick for you guys. I like doing this to kind of help show you guys the colors. So I'm going to do this right here. And I'm going to put that x squared here. This right here is kind of like our little reminder. We're trying to figure that out. And this over here goes in our last box. All right, so obviously, we're going to do x times x because that's how all the problems have been so far. So what times what gives us 4? Yeah, 2 times 2. Now, here's a problem though. I forgot to put this that way. Oh, that is a plus. Never mind. That was my bad, guys. I thought this was a minus because of how I circled it, but it is a plus. So yeah, 2 times 2. Let's pretend that I didn't know that, and for some reason I'm like, 1 times 4. Yeah, that should work, right? Okay, let's try this out. Well, this is x, and this is 4x. Well, x plus 4x is 5x. So what this tells me is that I didn't get it wrong. I just found a way to not do it. And a lot of times when you're using the box method, guys, you are going to find a lot of ways to not do something. I think it was it was Thomas Edison that said what what did he say after they asked him why it took him like 1,000 times to fail to make a light bulb? And he's like, I didn't fail 1,000 times. I just found 999 ways to not make a light bulb. And that's what I'm giving you guys with this box method. It's kind of a way to figure out if this works or not. So now this is just going to be x plus 2 times x plus 2. But wait a minute, these two are the same thing. So I can just square them. Whenever you have two things that are the same, you can just square them. Anything, so a times a is a squared. This is that same idea. So what's going to be my only answer for this one, guys, if I have an x plus 2? Anybody? Oh, that's the problem. You know what? I don't think I asked it right, to be fair to all of you. What can I plug into this x to make it 0? Is what I was supposed to say. I don't even remember what I did say. But what can I plug into this x to make it 0? Because remember, we're making this equal to 0. Yeah, it's negative 2. I don't know why my keyboard didn't do the negative. There we go. Negative 2. Good job, guys. All right, so let's move on to the next one. So it's going to be a lot of this trial and error stuff. So one thing that I haven't shown you guys yet on using this box method is you want to try to make this as small as possible. The reason why that is sometimes Let's say you want to divide something out. You could probably divide something out of all of this. So remember when I was talking about that backwards distributed property where we have something here and we're distributing it? You want to make sure you want to do that backwards distributed property before anything else. So these ones over here, they didn't have anything in the front for us to distribute. You couldn't divide by x because this didn't have an x. So that's why I haven't mentioned it until now. They haven't given us a problem to practice that backwards distributed property. Is there something I can divide all of these by, like the coefficients, these numbers in the front? Is there anything I can divide there? Yeah, I can divide it all by 2, which is going to give me this. So after I divide everything by 2, I get this. Now that I divided everything by 2, I factored everything by 2. Now I can use my box method. Sometimes you will still have a number here at the end, but before that, you always kind of want to make sure that you can't do this backwards fact factoring. You want to do this backwards distributed property. Sorry, let me drink some water. I think my throat got a little dry there. So that's what we're doing here. We want to make sure we're doing this backwards distributed property, also known as factoring. So in math, whenever we're taking something out, it's called factoring. And the reason for that, a factor is what makes a product. What makes a product. And the reason for that is think of it like this. If A times B equals C, C is our product, but A is a factor and B are both factors. So that's what it means by factoring. That's why it's called factoring is you're taking out this 2 because 2 is a factor of it. So in case you guys are ever like, well, what is factoring? That's what it is. It's basically dividing because it makes something else. So here we're going to use our little trick again. I'm going to use different colors. So this one, and let's not forget our middle one. That red looks very close to that orange. So we have this, we have the -2, and we have our red number out here. So this is going to give us that x, and then what times what gives us -2, guys? And I'll answer at once. So what times what gives us -2? Yeah, -1 times +2. Let's check this out. So if we do this, we get -x and 2x. But I came across a problem here because if I add these two together, I get +x, not -x. So I love that we did that one. The reason being is because I got the right number. I just got the wrong symbol. So what I want you guys to remember is if you get the right number but not the right symbol, all you have to do is switch these. Now this makes this -2x and it's going to make this +x. So guess what? Now that I circle these, now I have the right symbol. So if you guys get the right number but not the right symbol, you're halfway there. All you have to do is just change your symbols. So from here, we're going to get this x plus 1 and this x minus 2. So my answers become x equals -1, x equals +2. So that's all we're doing here. And I'm going to start answering these guys because we are starting to run out of time and I want to make sure I get through the whole lesson. But I will start. Do you guys like it being more interactive where I'm asking you guys these questions? Or do you guys just want me to rush through it like I was doing the first lesson? Okay. Cool. So I'll start trying to ask more questions. This also gives you guys a chance to like show what you know, and also sometimes I don't want you guys to feel bad if what you're saying isn't the right answer, because here's the thing: if you guys don't say it, you guys might go through life thinking about it the wrong way. So it's a good thing to just kind of like, this is what I think. And if you don't know, I'll explain to you why it doesn't apply to this case. So basically, just don't be afraid to answer it. Another way of doing this um, is the quadratic formula. So they're going to get into this quadratic formula. What I want you guys to know is these are all letters. This is your A, this is your B, and this is your C. And that's how we're going to plug this in here. So looking at this one, can someone tell me what our A is for this formula? This one right here. What's our A? It's not 6. 6 is actually our C. So -6 would be our C. 10 is our A, exactly. So that tells me that wherever I see an A, I'm going to write 10. And Nelson already said what our C is. So every time I see a C, I plug in -6. What am I going to plug in when I see a B? Yeah, 11. Now, here's one thing, guys. See how this is negative B? You're always going to write B with a parentheses. The reason being is, let's say this was -11. It would be -11, which would make it positive. So just make sure you're always watching for that. So right off the back, I want to look for something that has a -11 in the front. So we know this one's not right. And we said that A is 10. So this one has 6 as our A. That can't be right. So we know that one's wrong. But this one has 10 as our A. That one's good to go. So our answer is going to be that one, literally just by knowing our ABC. So just remember, it's in ABC order. AX squared plus BX plus C. So from here, they want us to make this square. Oh, they're teaching us the box method now. So if we're multiplying this, we want to find the area. We want to find the length times width. 3 times its width. So the area is 48. So we have this box here, and this is 48. So what we're trying to do is we're trying to say that W times 3W is equal to 3W squared, which is 48. So if we have W times 3W, once we distribute, we get that 3W squared. So, wait, is it width and the area is this? Oh, they just didn't distribute it. So this is one of the reasons why I like you guys writing your work, because you never know what Adventum wants to have here. So in this case, they didn't want us to distribute it, so they just wanted this as our answer. And right here it shows us area equals length times width. So if you guys are ever in doubt when you guys are doing your practice problems, click this answer button and it'll show us. All right, so now it's going to teach us about graphing inequalities. So when you guys are graphing, a cool little trick is always have your letter on the left. If you have your letter on the left, let's say you have x is greater than 5. Well, in a number line, when you're graphing it, if you have a 5 here, you're saying x is greater than 5. So obviously, you want all the numbers from here going that way. Check this out. If you have your letter on the left, it's an arrow pointing that way. The one thing I do want to talk about though is when you have a less than or sign versus a less than or equal to sign, or a greater than sign versus a greater than or equal to sign. When you're graphing, let's say we have x is less than 5. So again, we're going to use our cool little trick. This is on the left. So here's our 5. If it's less than, it's an open circle and it goes that way. Again, our little arrow trick. But let's say this was less than or equal to. That means we want to include this 5. So this circle isn't empty anymore. We want to include it, so we're going to fill it in. When we're graphing with two things, later on we'll see that this is the difference between a dotted line and a solid line. So let's go through these real quick. Again, here we go. It's less than or equal to, so they filled out the line here at the 4. And they're just solving it just like it was a regular line. The only time we're going to have something tricky is when we get to a point like this. We're going to have to divide by -3, and all the signs change. So this becomes x is greater than -4. So just keep that in mind. When you change the sign, divide by negative or multiply by a negative, all of the signs change. This isn't a positive anymore, it's a negative. This isn't a negative anymore, it's a positive. All right. And here's that rule. So if we divide by a negative, we're going to change that sign in the middle. And they're just going to go over it in detail here. Think of it this way. If you're talking about negative x's and you're talking about something less than, you're going to go this way because we're talking about negative x's. But now we're talking about positive x's. So if we're talking about a positive 10 and our x's become positive, we're going to be going this way because we're not talking about negatives. So like think of it this way. If I have a -2 and I'm talking about less than -2, but I'm talking about +2, I'm going to talk about everything over this way. So that's kind of a good way to remember why these signs change. All right, and then we're going to do the x. The number x is greater than or less than. So again, we want this. Is the circle filled in or closed, guys, if it's an equal to sign? Filled in or closed? Oh, guys, that brings up a good point. If you guys don't like listening to that voice every single time, you can click this guy right here, this little speaker thing, and turn slide narration off. So I know what a lot of you guys do is you guys are doing it, and then you're like, oh, let me hit the speaker button over here to make him go quiet. You can actually just permanently have that off. So if you guys are annoyed at hearing that every time you do a slide, you can just have it turned off the whole time. Mhm. Yeah, it's just that monotone. But what do you think, Sammy? Is it going to be filled in or closed? Is it going to be an open circle or a closed circle? Yep. And it's an arrow going that way because we have this on the left, so we know it's this one. Cool. Is everybody kind of understanding the open and close? Cool. Oh, and then I saw Julia, you answered. Sorry, I had like this big notification covering the bottom of the chat, so I didn't see it right now. All right. So when we're doing this one, I'm going to go over this really quick, guys, just because I know we're running out of time. But the idea here is we're going to solve this like we're doing regular. So we're going to add 2. So we get x is less than or equal to 5. If you guys think I'm going too fast, just type it in the chat or go, can you go over that really quick? I just want to make sure we have enough time to kind of cover the most we can. 5. So that's all we're doing. We're just solving it like a regular equation here. So if we go to the next one, this one we're dividing, but we're not dividing by a negative number, so we don't have to worry about our sign changing. So it's still going to be less than because we didn't change the sign, and it's still negative. So what we're going to do here is we're just going to type in m is less than or equal to -2. Okay? And we're moving on to the next one. So right off the bat, guys, is this going to be an open circle or a closed circle? Before we even do any work, open or closed? Open, yeah. There's no equal sign, so it's an open circle. Now from here, I already know this can't be the answer. So sometimes process of elimination really helps out here. We're going to subtract the 3. We're going to subtract the 3. We get half of x. You think it's the second one? Let's check this out. Times 2. So we get t is greater than 4 because we're multiplying by 2. So yeah, exactly. It was the second one. Good job, guys. And this will explain it. So even if you guys get it wrong, click the answer. Even if you get it right and you're like, that's not what I was expecting, click it. It shows you the steps. It's good practice for your mastery test. All right. So here we're going to be talking about solving this equation. Well, guess what? This one's really simple. I was kind of worried that this was going to take long, but when I reviewed it, I was like, this isn't that bad. 2nx. We're not going to learn about logs. I know I've covered it in my pre-calculus class, but here we don't really have to worry about logs. That's the only way to get rid of a base is with a log. But this one's pretty simple. If this is 2, we don't know what this is, and this is 2, well then x has to equal 5. That's just how it works. Everything's the same, so that means that x has to be the same as that other x. So this is 5. What property did you use here? So blah blah blah. So here, this one's tricky. They want to talk about 3 to what power gives us this. I'm going to show you guys a cool little trick. So we know this is an exponent. So what we're doing is we're just doing 3 times 3 times 3 times 3 a bunch of times. So what I'm going to do is I'm going to keep track of how many 3s it takes me to get the answer. So I'm going to go, so 3 times 3. So that's 2 3s. That's still too small. The third 3, 3 number 4, 3 number 5, 3 number 6. So it took us 6 threes to do it. So if I do 3 times 3 times 3 times 3, 6 times, I'm doing 3 to the 6th power equals 729. 729. Sorry about that, guys. So what I'm going to do here is I'm going to use my equation editor because I don't know how to do exponents without my equation editor. That's that little yellow button. 3 up 6 equals 729. Okay, now I have it all nice in my little equation editor. All right. You can also use the property of this. So this is this weird. So what they're saying here is since these are the same, we can just go like x minus 3 equals x squared minus 9. So from here, what we can do is we can bring this x over by subtracting. And then we can add this 3 and we can add this 3. So we're kind of doing the opposite. So now what we're doing is we have this equation x squared minus x minus 6. Because this 3 and this 9 make a minus 6. And from here we can do a box method. So again, guys, I'm sorry I'm going kind of fast, but that's what the video is going to be for. Does everyone understand this so far, though? Cool. So here we're going to do this. Our goal is to get this negative x. So I have x, x. I want to get a negative 6. So I'm going to do negative 3 times 2. And this is 2x. This is negative 3x. Oh, guess what? If I add these together, I get that negative x. So what's happening here is I have x minus 3, x plus 2, and this is all equal to 0 because I moved everything over, so it's equal to 0. So then my answer is x is positive 3, x minus 3. What you guys can do, I don't think I can do it because I'm not a student, is you can always take a screenshot or take a picture of whatever you're doing to show your work. So you can take this picture and you can just paste it onto here. I don't think it's letting me, but another trick you can always do, I don't know if this lets me do it, is you can do this. So I took a screenshot and then I'm just going to save this. Oops, no, I didn't want to take a new one. Well, let's say I'm going to take a new one. If you guys need help doing screenshots and stuff, let me know. I can always show you guys. Usually I use the print screen button. If you're using a Chromebook, I can show you how to do that later. But I'm just going to call this work. Later on, you're going to have to name it other stuff. And I want to insert an image. So I click insert image from my computer. And I think I saved it to my desktop. So this way, you don't have to show your work every single time. It's like, well, why did you do this? It's like, I already wrote it down on paper. Let me take a picture with my cell phone and let me post it on there. That way you don't have to type all this stuff in. You never showed us how to upload pictures from our phones to show our work. Thank you for bringing that up. Does this kind of answer that question, Brianna? How to upload pictures? Kind of. All right. Um, I'll um, I'll I'll do that real quick right now because I have another appointment. I know I didn't get a chance to finish this. I'll finish the video. So there'll be 2 videos for this class up. So you get that way you guys can do the work. But what you want to do is, let's say you're taking a picture. Take a picture, connect your phone to your computer. So let me see if I can do that right now. So what I'm doing is I'm literally just grabbing my cell phone and plugging it into the laptop. Or what you can do is email yourself. So you can always email yourself a picture and save it to the computer. So let's pretend doing it with the cell phone's a little tricky. So what you do is you insert a picture, go here. You're going to want to find your cell phone. So where's my cell phone? So Victor's phone. And for some reason, it's not letting me do it right now. But normally it'll pop up. What I usually recommend doing is emailing the picture to yourself and finding out where it is. So save it to somewhere where you know where it is. I usually honestly just save it to the desktop. I click open and it saves it. Does that make a little more sense, guys? Yes, no, maybe? Okay, that makes sense. Cool. So that's how you can show your work. So take a picture with your cell phone, email it to yourself, save it. It's a little bit more work, but trust me, that's going to be a lot better than typing in all the steps. And after a while, you're going to get better at it. So for right now, I'm going to finish this video on my own later because I do have to get to my other appointment. So sorry about that, guys. I think I got a little too carried away. Oh, but the next ones are just practice problems. Oh, so we did cover everything in the lesson. There's just going to be combination stuff here. But for the most part, you guys should know everything. If you guys need more help, make an appointment with me. But for everything else, it looks pretty much like everything we've already learned. So we actually ended in a good spot. I'll just make a short video with some of these problems and also finishing off this activity. So it's only a few more problems. It'll probably be like a 30-minute video or something. All right. So sorry about the time, guys. It's always crap for time, but I'll see you guys on. This is Tuesday. I'll see you, or Thursday. I'll see you guys next Tuesday. All right. So try to get the work done for the modules that we've completed so far. Have a great day, guys. You too, Nelson. Bye.